One of the beloved quotes from the world of astronomy, famously stated by the late astronomer Carl Sagan, highlights that the number of stars in the universe exceeds all the grains of sand on all the beaches on Earth. Understanding this idea is challenging. When you stand on a beach, you can see countless grains of sand. Considering all the beaches on Earth, the total number of sand grains increases exponentially. Yet, according to Sagan's famous quote, the number of stars in the cosmos is even greater than the number of sand grains. It's a number that's truly hard to comprehend. Those familiar with astronomy have likely heard this quote at least once. However, Sagan's statement, like many other profound and unbelievable quotes, deserves a very fundamental question: is it really true? Finding an answer depends on many assumptions that need to be considered, and determining some of them is not straightforward. First, let's look at astronomy. For example, our Milky Way is a large galaxy containing hundreds of billions of stars. In fact, pinpointing this number is quite difficult because we are inside the galaxy, and our view of a large part of it is obstructed by gas and dust. It's important to note that stars can exhibit a wide range of brightness. We can refer to a conservative estimate of 200 billion. Now we just need to multiply 200 billion by the number of galaxies in the observable universe to find out how many stars there are in total. A team of astronomers working on this issue published their results in 2016, stating that there are nearly 2 trillion galaxies in the universe. So can we multiply 200 billion by 2 trillion to get an answer? Unfortunately, it's not that simple. The astronomers who estimated 2 trillion only considered galaxies whose total star mass is more than 1,000,000 times that of the Sun. 1,000,000 times the mass of the Milky Way is about 200,000 times less. As a result, we cannot simply use the Milky Way as our model. The good news is that less massive galaxies, like stars, are probably far more common than more massive galaxies, and thus, their greater number compensates for their smaller population of stars. Using 1,000,000 solar masses per galaxy is likely close enough. But there's another issue. 1,000,000 solar masses does not mean 1,000,000 stars per galaxy. The Sun is unusually massive compared to most stars, as many of them are actually smaller, cooler red dwarfs. Stars with solar mass or greater make up only about 10% of the total stars, so in the universe, there are roughly 10 stars for every solar mass. We need to multiply that 1,000,000 solar masses per galaxy by 10. This gives us an average of 10 million stars in each galaxy. How much sand is there in every cubic meter? The answer depends on the size of the grains, which can range from under 0.1 millimeters to about 2 millimeters. Let's estimate it at an average of 1 millimeter. A cubic meter then contains 1,000 by 1,000 by 1,000 equals 1 billion grains of sand. This is an enormous number for just 1 cubic meter. Just a few hundred cubic meters of sand, about the size of an average house, would suffice to match all the stars in the Milky Way. Thus, to equate with a large galaxy like our cosmic neighborhood, we don't need a vast amount of beach sand. The assumptions in this scenario are very superficial, and this can significantly alter the results. Consider the size of the sand grains. If they are on the smaller end of the range at 0.1 millimeters, there could be more than 1,000,000,000,000 grains of sand in each cubic meter, meaning we would have to multiply the total number by 1,000. Even if we estimate the length and depth of sand on a beach to be several times less or greater, the sand wins by several thousand times over the stars. On the other hand, 10 million stars per galaxy may be too low an estimate. It's possible that most galaxies have far more stars than that. However, it's still likely that stars cannot match the vast quantity of sand on Earth's shores. It should be noted that we only considered the sand on beaches. If we look at the ocean floors in deserts, the number of grains of sand skyrockets to unimaginable levels. The Sahara Desert likely has hundreds of times more sand than all of Earth's beaches combined. Are you surprised by the result? The beauty of quantitative reasoning lies in this. You can quickly arrive at rough estimates and see how far they are from your expectations. Our brains are not evolved to comprehend such massive numbers, so it's not unexpected that our perceptions might be far from reality. But that's what mathematics and science are for, to prevent us from deceiving ourselves.